Hi, I'm Anthony Makepeace, student number 1800246255, and today I'm going to talk you through my AutoBlind project. The Smart Home Association defines smart home technology as the integration of technology and services through home networking for a better quality of living. Over the last decade, the term smart technology has exploded, with more and more of it finding its way into our homes. Smart technology is not only designed to make our lives easier, but is in fact allowing elderly and disabled people to stay independent in their own homes as long as possible. This project looks into developing a smart home device which would give a benefit to everyone, including those with disabilities or a limited range of motion, and give a better quality of living. The project was aimed at trying to ease the daily task of opening and closing roller blinds, with custom roller blind solutions costing a minimum of £146 and standalone options being £99. I aimed to create a cheap product which could be installed onto existing blinds. The final aim was for the product to be usable by all age groups and abilities, with any interface being accessible and easy to use by all. For the front-end app interface, Android Studios was used. Built on top of JetBrains IntelliJ is the official IDE for Google's Android OS. Amazon Alexa was then used, partnered with If This Then That as the other interface for the system. IFTTT is a free platform that allows users to easily connect apps and devices together. For the hardware, a Raspberry Pi Zero W was used with the Raspbian, a Linux distro designed for the Pi. The Zero W is a super hackable and ultra-low-cost computer which has 40-pin GPIO and 2.4 GHz 802.11n Wi-Fi capabilities, making it perfect for the project. Connected to it was a GWS S35 continuous servo which would drive the blind. The main screen was created as an easy, intuitive way to control the blind. Two simple buttons were used which clearly stated how to open or close the blind, whilst a progress bar was designed to look like a window and blind, which allowed the user to select varying openness of the blind by intuitively dragging the bar. When opening the app or clicking the refresh button, the app requested the current position from the server and updated. The second screen was a settings screen. For this project, the only two settings needed were the ability to toggle open, auto open close, and set the times for both. This was achieved through the use of time pickers and a toggle switch. When the user toggled the time on/off or set a new time, the date was pushed to the server to be saved. Finally, a simple widget was then also created which allowed the user to quickly open and close the blind from the home screen without the need to open the app. There were three main Python scripts used. The first one was a socket server which took incoming connections, passed the requests, and if it was a post request, would either write it to the file for the time or send it to the server controller. If it was a GET request, it would then return the time or the position, depending. In the server controller, first of all, it would set up the wiring that was needed. It would then pass the incoming command. From there, it would then get the current position of the blind and then move the blind the needed amount to get to the final position needed. The third was a time activation. Now, this script was used as a cron job, so it would read in the data, the time data. It would check it against system time, and if needed, it would either open or close the blind. IFTTT applets were then used so that you could use Alexa to say phrases like trigger open the blind, and then it would make a web request to the socket server on the Pi using post request to open or close the blinds. To assemble, the motor was connected to the Raspberry Pi using a power, ground and signal cable, and then cog off an existing blind was drilled and keyed to the existing motor so that when the motor rotated, the cogwheel also rotated. Everything was then measured and a case was 3D printed to house all of the components. After sanding, drilling, filing and unfortunately losing two of the mounting pins, the components could be inserted. First, the Raspberry Pi is slotted onto the mounting posts. The motor is then inserted into the slot and its beaded chain aligned on top. The securing plate can then be added on top of the chain and the lid placed on top. Finally, power can be added to the project through the notch in the side of the case. Now that we have the blind successfully connected to the device, we can use controls on the Android app to first of all move it up. Unfortunately, because this blind's heavy, we've got to kind of give it a bit of a hand. We can then just hit the close button. And this will then close the blind. Or we can use commands such as Alexa, trigger open the blind. That'll go through the IFTTT servers. And then sure enough, again with a little bit of help, with two fingers to help it you. So trying to get there. And to move back to the starting position, again we close it on the app. And now close it halfway. Some ideas for future work include adding manual buttons for opening and closing so you don't have to use the app or Alexa, including a light sensor for dawn and dusk settings, mounting hardware to secure to a window frame, or using gears or a higher torque motor so you can use with a heavier blind.